Okay, so the first half of today's notes is very easy. It's just basically applying all your Algebra 2 rules. The last 3 problems, it gets a little harder. So the directions are operations on complex numbers. Okay? And what it'll do is it'll give you it will define for you some variables. So it'll say, for example, let's say u equals -4 plus I, and v equals 1 minus I, and w equals -3 minus 6I. So there are your 3 different variables that it defines for you, u, v, and w. And then you're just going to perform different operations on those variables. It's very basic and straightforward. So for example, number 1, it's going to ask you to take u plus v. All right, add them together. I mean, this is pretty easy. So if you're asked to add u plus v, you're going to say, all right, I want -4 plus I, because that's u. I'm going to add it to v, which would be +1 minus I. Okay, when you write your final answer, you'll notice that the number is written first, and the complex part, the imaginary part, is written second. So the real first and the imaginary second, always in the same order. So I'm going to combine the real, -4 and 1 make -3. And what happens to the i's? They cancel. So there's your answer. Okay, now number 2. Number 2 is the one where you're going to make your mistakes on all the time. It looks pretty straightforward and easy, but it's the minus that will throw you off every time. U minus v. And guys, if I want a minus v, means I want the opposite of everything that's v, right? So I'm going to write my u down, which would be -4 plus I, and put a huge star right here so we don't forget the minus. I want the opposite of v. So that means v is 1 minus I. So I want -1 plus I. The opposite of everything. Now combine like terms. Real and then imaginary. -4, -1 make -5. And I plus I makes 2I. Number 3. Number 3, this time we're going to do a little multiplication. So on u times v. Okay, so we're going to multiply u times v. So u is -4 plus I again, and v is 1 minus I. Right, exactly. I heard it a couple of times. You're going to have to FOIL. These are binomials that you're multiplying together. Connor, these are the 3 variables right here to define. We're taking international. Okay, so we're going to FOIL now and just distribute. So -4 times 1 is -4. -4 times -I is plus 4I. I times 1 is I. And then be careful here. I and -I multiplied together. What's I times I? I squared. But a positive and negative make actually a -I squared. Okay, back to Algebra 2, and I think we've even done it here in pre-cal. What is the value of an I squared? Oh, shoot. What's close? Oh, negative. It's a -1. Okay, the value of I squared is -1. Okay, the value of I squared is -1. So, if you look carefully then here, this is kind of tricky. If I squared is -1 and I want minus I squared, what do I actually have there? +1. Do y'all catch that? This actually is a -1. So if I want the opposite of -1, you're just going to cross it out. That's what I like to do and say, okay, I really just want a +1 there. Now combine your real numbers together. So -4 and a +1 make 3. And then 4I and another I make 5I.
So your final answer should never have an I squared, correct?
Correct, good question. He said your final answer should never have an I squared because I squared has a value of -1. Good question. -3, thank you. Thank you. Okay, now, let's go to number 4. Number 4 is a little bit of division. U divided by V. U divided by V. So I want -4 plus I divided by 1 minus I. Okay, this one's strange, okay? I don't know if you remember, but if I have an I in the denominator, don't remember where I actually comes from? The square root of what? That's right. It comes from a radical. Yeah. An I meant you have the square root of a -1. The square root of -1 is actually written as an I. So if you see I in the denominator, it's really a radical. Are you allowed to have a radical in the denominator? Nope. So are you allowed to have I in the denominator? No. Okay? So we have to get rid of it. You guys, on the last unit that we did not make you, remember we would leave answers as like 1 plus square root of 3. We didn't make you get rid of the radical in the denominator. We're going to actually do that for this. Okay, you can't leave it. So to get rid of it, the thing that you do, when you have a binomial in the denominator that you need to get rid of, you multiply by its, what they call a conjugate. Okay? And you've done it before, but it's 1 plus I. Okay, and let me explain why it will get rid of it. And I'll show you up here for just a second. Here's another think bubble. If I say x plus 2 times x minus 2, okay? If I multiply those together, if I FOIL them out, I'm going to get x squared plus 2x minus 4. Okay? And what happens is these, every time, they have opposite values. These have opposite values, so this will have opposite values. So every time you multiply conjugates together, the middle terms, they go away. So now they're gone. So your answer is just x squared plus 4, or minus 4, I'm sorry. X squared minus 4. Okay, what went away? This is my answer. The 2's went away, correct? Well, if you have a situation like this, where I want this I to go away, if I'll multiply it by its conjugate, just like the 2's went away, these are exactly the same, the i's will cancel. Okay, just like up here, the 2's canceled. One's positive, one's negative. When I FOIL, they go away. Up here, one's negative and one's positive. When I FOIL, they're gonna go away. Okay, and that's why that you do that. So let's, whatever you do to the bottom, you have to do to the top. So let's actually find the answer then. So I'm gonna FOIL the bottom. 1 times 1 is 1. Okay, then you're gonna do plus I. Now you're gonna FOIL the negative I. So negative I. And at the end, a negative I and a positive I make a negative I squared. And like I said earlier, what's happening to those i's now? What do they do to each other? They what? They cancel. Excellent. And what's the value of a negative I squared? We talked about it before. It changes the sign, so plus 1. So we're going to write this as a plus 1. So what do I have in the denominator now? 1 plus 1 is 2. Okay, now let's FOIL the top. So 4 times -1 is -4, and so forth. FOIL the top. When you FOIL the top, if you see an I squared, you better change it. You'll never have an I squared left. So what are we going to write as this I squared? -1. Good job. It's positive this time. So we're going to actually cross it out and put -1. So combine the reals. So -4 and -1 make -5. And you combine the imaginary, and you get minus 3i. Number 5. V times W. V times W. Okay, so this time you're going to do a binomial and a binomial. So you have to FOIL. Okay, try it. Write them out and start to FOIL and see what happens. Should end up with -3 minus 6i plus 3i plus 6i squared. What are we gonna write instead of plus 6i squared? What is that gonna actually be? It's like taking 6 times -1, right, which is -6. Combine the real numbers first, so you have -9, and then the imaginary numbers with your -3i. Okay, now let's do number 6. Question?
Plus 3i or minus?
Well, -6i and a plus 3i would be -3i. Number 6 is another division problem. Let's try it. V divided by W. It's another division problem. V over W. Okay, which is gonna give us. Oh, we already did that, I'm sorry. Did we do V over W? Okay, I'm sorry. So 1 minus I over -3 minus 6i. What do you have to do to solve this? If you have an I in the denominator, it's not allowed to be there, so what do you have to do? Multiply by its what? Conjugate, right? So let's do that. Multiply by its conjugate, -3 plus 6i. Whatever you do the bottom, you have to do the top. And that's how we get rid of the i's. So if you FOIL the bottom, you end up with 9 minus 18i plus 18i minus 36i squared. Now, these will cancel, and this is a -36 times a -1, so it becomes a plus 36. So in the denominator, you have 9 plus 36, which is 45. Now do the top. So you're gonna have -3 plus 6i plus 3i minus 6i squared. Combine like terms. This becomes what? -6 times I squared is plus 6. So I've got 3 plus 9i. Can that be my final answer? Anybody know? Can I leave it like that? I can, I'll lose points. Right, because what fits into a 9, a 3, and a 45? What fits into all of those? A 3. So you end up with 1 plus 3i over 15. Guys, don't leave it. If it can be reduced, reduce it. Okay, here's number 7. U times W. U times W. fill it out. Don't forget not to leave your I squared. So you're gonna change the negative 6i squared to plus 6. So 12 and 6 make 18. 18 plus 21i. Okay, I'm gonna give you two problems. I want you to do W minus U. And I want you to do U divided by W. I'll give you a few minutes to try both of those on your own. W minus U and U divided by W, and let's see if you have the hang of it. I think for the most part, y'all are pretty good. Let's give it a try.